from our Memorial Day weekend. Hopefully you had a really nice relaxing one. You might hear my dog bark a few times in the background because there's a dog barking in the neighborhood and she can hear them. But welcome back. It's time to get back to work. So excited for that, aren't you? No. I just want to remind you or to tell you, and if you would look on the homework calendar, you'd see that I am not in on Tuesday, which is today. I took an extra day of vacation. I am around, but I will not be answering emails. I will be cleaning my house. So I'm taking an extra vacation day. You can reach me Wednesday through Friday this week. If you want to Google Meet or whatever you want to do, I'm happy to do that to work on these problems with you. But I did not give you a lot of work this week because of the short week. And this week's stuff is a little difficult. So hopefully you can get through it. I'm not trying to scare you. You can do this. We're going to start with operations in scientific notation, addition and subtraction. Okay, we're only doing addition and subtraction. So the actual learning targets will be performing operations with numbers written in scientific notation. And you will know you are doing a good job if you can add and subtract numbers in scientific notation and explain how to do it. Okay. We will be doing multiplication and division later this next week, and then you'll be using both to solve real life problems. So right now we're just going to be explaining addition and subtraction. So really just one part of your 8.7. Okay. So for your notes today, to understand scientific notation and how to use operations in scientific notation, to understand to add or subtract numbers written in scientific notation when they have the same power of 10, or add or subtract those numbers, those factors only. When the numbers have a different power of 10, you need to change the power of 10 so they are the same. Okay, so let me repeat that. When you use scientific notation and you're adding or subtracting numbers that have the same power, whether that 10 to the negative 4, 10 to the 2, if both numbers have the same power, you just add or subtract the factors and change their answer into scientific notation. But you will also have times when you have numbers with different powers of 10. And in that case, you want to change them to the same power of 10 and then add or subtract. So we're going to be doing both of those types of problems, and I'm going to give you one alternative way to do the second part, which is when you have different powers of 10. So here's what the same power of 10 would look like. Find the sum or difference. For part A, it says 4.6 times 10 to the third plus 8.72 times 10 to the third. And you notice they both have the same power of 10. So first thing you want to do is, it says find the sum or difference. What is the sum or difference? Well, sum means to add, and in this case it's an addition problem. So we are finding the answer by adding. Oops. So let's start out with our problem, and what we wanted to do, and I had said it before, was that we wanted to add the factors only. 4.6 and 8.72, add those two together. Remember when you're doing this, by the way, by hand, that you would line up the decimal points, okay, in order to add these numbers together. And when you do that, you get 13.32 times 10 to the third. Okay, so when you're adding just the factors, just the parts that have you're not doing anything with your power of 10. You're just adding your factors. Your powers of 10 are the same, so you're just going to add your factors and attach it to that power of 10 times 10 to the third power. Okay, that's the first part of what you do. Then your next part you need to do is rewrite this in scientific notation. 13.32 times 10 to the third is not scientific notation. Why isn't it not scientific notation? Hopefully you remember from last week that the first number in scientific notation must be greater than 1 but less than 10. 13 is greater than 1, but it is not less than 10. Okay? So we need to rewrite this in scientific notation. The first factor must be between 1 and 10. 13.32 is not. So in order to make that into scientific notation, I'm going to multiply it by a power of 1. That means I'm just going to move the decimal point one place, right? Oops, I don't want that. I'm going to move the decimal point one place over. So in order to do that, what I really did was multiplied by a power of 1. The decimal point would end up here, which would give me 1.32 times 10 to the power of 1. And then I also have that power of 3. When I add those together, I get 4. So the total answer here is 1.332 times 10 to the 1 plus 3, or 10 to the 4th power. Notice I changed it to this 13.32 to scientific notation, and then I added my powers of 10 together to find my answer. Okay? Be careful on these. They can be difficult. Different powers of 10. Okay? 3.5 times 10 to the negative 2 minus 6.6 times 10 to the negative 3. Notice my answer, or my powers, are different. I have a negative 2 power and a negative 3 power, and I cannot do anything with those until I change them back to the same power. They need to be the same power. Okay? So I'm going to start by rewriting 6.6 times 10 to the negative 3, this one, so that it has the same power of 10 as 3.5 times 10 to the negative 2. Okay, so how do I do that? 10 to the negative 3 can be written as 10 to the negative 1 times 10 to the negative 2. Negative 1 plus negative 2 makes negative 3. So why did I choose this configuration? Because I have a negative 2 power that I'm trying to match. Okay, there's my negative 2 power. So once I have rewritten this, I can now change my 6.6 times 10 to the negative 1 and then times 10 to the negative 2. That will give me this negative 2, and this is how you would change the problem. So I'm rewriting 6.6 so that it has two powers of 10, one of them being the same as or matching the other factor, or the other part of the subtraction problem. Now that I have this 6.6 times 10 to the negative 1, I want to fix that. I want to actually do this part of the problem. 6.6 times 10 to the negative 1. If I actually do the problem, I get 6.6. I move the decimal point two places. So I get 0.66. And then this particular part of the problem has been solved. And all I have left is to put this back in the equation. Now I have matching powers of 10. Okay? I can subtract my factors. I have 3.5 times 10 to the negative 2 and 0.66 times 10 to the negative 2. And now I can actually do the subtraction of these. Remember again, you want to line up your decimal points to subtract. You could also do this on a calculator. That gives me 2.84. Now I can make sure I write this in scientific notation. 2.84 times 10 to the negative 2 is my answer. Wherever I put it, it's here somewhere. There it is. Let me go back. Here we go. That's my answer. Okay, so let me state what I did here. First, I have two different powers of 10. I need to rewrite one of them so that it has the same power of 10 as the other. I chose the 6.6. I knew I could rewrite 6.6 times 10 to the negative 3 as 10 to the negative 1 and 10 to the negative 2. When I add my exponents, I get negative 3. Negative 2 is the other matching exponent of the other factor in this problem. So I can go ahead, start to solve this by changing 6.6 first times 10 to the negative 1 and then bringing down that negative 2. Now I can add or subtract my factors. We're subtracting here. And then I attach my -2 to it, my scientific notation. Yes, that is a lot. And it seems very hard. Just for your information, you can rewrite different powers of 10 so that they match, but you don't necessarily, I chose 6.6 times 10 to the -3, but I could have also done it using this one, 3.5 times 10 to the -2. I could have written that as a -3. Okay, it would have been -1 plus -2 makes -3. So if I made this, I would just rewrite it this way so that they had the same factor. Okay? All right. Finding the sum or difference. First thing we need to look at for your first try it. Is it sum? Are we adding or are we subtracting? In this case, we are adding. We are finding the sum. The second step, do they have the same power of 10? They do not. Okay? So this is going to be a harder problem to solve, but we will be able to do it, not a problem. So what do we need to do first? We need to rewrite them so that they have the same power of 10. I'm going to choose to, you can either rewrite 8.2 times 10 to the 2 or 3.41 times 10 to the -1. You can change either one of them to the others, to match the other's exponent. I am actually going to choose 3.1 times 10 to the -1. Okay, somewhere here. Uh-oh. I think I just moved everything over, so, well, we'll see. Yes, I did. 3.41 times 10 to the -3 times 10 to the -2 will give me that, or to the +2 will give me the matching exponent that I want. 10 to the -3 plus 2 makes the matching exponent here. Okay? So then when I go to solve this, now I have matching exponents. But the first thing I need to do is change this 3.41 times 10 to the -3. Whoops. I am messing this up. Here's my 3.41 times 10 to the -3. I move it 3 places. That gives me 0.00341. And then I have to add that times 10 to the -2 because I've already changed the 10 to the -3. So I end up with 8.2 times 10 to the second plus 0.00341 times 10 to the second. So now I know that I just have to add or subtract my powers, and in this case I'm adding, which means that I do 8.2, I lost all my stuff here. I do 8.2 minus 0.00341, and I know I can put my zeros in if I need to, okay? And when I add them together, I get 8.20341 times 10 to the 2. And is my answer in scientific notation? Well, this actually is in scientific notation, so that would be my answer right here, 8.20341 times 10 to the 2. I don't have to change anything else. This number is larger than 1 but less than 10, and they have the power of 10 attached. There's an alternative way to do this problem. That is a lot to remember, going back and changing exponents. It might be easier for many of you, or for all of you, to just change both numbers to standard form right away. What does that mean? That means solve 8.2 times 10 to the 2 by moving the decimal point over, okay, 2 places. Okay, that gives you 820. And solve 3.41 times 10 to the -1, that moves the decimal point 1 place over to the left. And then, once you've done that part, you just add or subtract your numbers. Okay? So we're adding or subtracting 8.2, or 820, sorry, plus 3.41. Remember to put in your zeros. There would be 3 zeros here as well. And then when you add, you get 820.341. And we need to turn this into scientific notation. Okay. We need to actually move the decimal point 2 places. When we move the decimal point 2 places over, we get 8.20341 times 10 to the second power. Okay? Because we moved it 2 places over. Does that make sense? So change both to standard form, add or subtract, convert back to scientific notation. This is the easiest way to do it, I think. Okay? This way, that's a lot of work. All right, try it. Number 2. Same or different powers of 10. They are the same. So are we adding or subtracting? We are subtracting. We're finding the difference. Okay? Has the same power of 10. So really, we're just going to subtract our factors. 7.8 minus 4.5 gives me 3.3, and they're both 10 to the negative 5. Is my answer in scientific notation? It is, okay, because this number is greater than 1 but less than 10. If it wasn't, you needed to do the product power property and add or subtract to finish rewriting in scientific notation, just like we did in question 1. All right, that's a lot, okay, and they're harder problems, but you can do it. Do your best that you can. When we do multiplication division, they're much easier. So what is your assignment? It's 8.7, scientific notation, addition and subtraction on big ideas. And guess what, folks? I made it so easy for you. There's only 6 problems. All the answers, though, have to be written in scientific notation. So even if you did these on a calculator, you would still have to take your final answer and write it in scientific notation. Do the best that you can. I made it even easier for you. I gave you no Alex topics this week. By the way, if you want to do them anyway, I will go back weeks in the past and give you credit for them if you've missed any weeks of Alex. So do those 6 problems and do extra Alex or do some Alex, and you'll be doing well. Use your extra time, though, if you're missing any assignments, to complete any missing work. I'm giving you an invisible ghost hug. It's invisible because I'm not there to hug you, but you might not be able to feel it, but it is there. Okay? That invisible ghost hug. So I miss you. Take care. If you need extra help, we'll meet up this week. You can contact me, send me an email. I'll try to work with you on it. Don't freak out. It's 6 problems, folks. Do the best that you can. We'll see you next time. Take care.